All right, we're going to actually start Chapter 5 now. All the graphing stuff that we did actually came out of Chapter 4, but we kind of bypassed that when we were in Chapter 4. Today is a lot of vocab, a lot of terminology. You will be required to know all the terminology that we're going to go over today, okay? Math-wise today, not hard math-wise. It's just a matter of learning the terminology and kind of using those. So first thing, this is called a polynomial. I'm sure you guys have heard that word before. Each part that's being added or subtracted together is a term. So how many terms does that one have? It has 3 terms. Do you guys know what you call something with 3 terms? A trinomial. Good, trinomial. Polynomial comes from poly, which means many. Nomial means terms. So polynomial just means has many terms. All right, so the degree of a polynomial in one variable, everything we deal with is in one variable, is the highest degree of its terms. So this example, the highest exponent that you see is a 3, so it has a degree of 3. So whatever the highest one is. And then the leading coefficient is the coefficient of the term with the highest degree. So in this example, since 5 is the highest, this has a degree of 5. And then the leading coefficient is the number attached to that. So leading coefficient would be -8, because it's just the number that's attached. So does this order bother anybody? It should, right? What should be listed first? The x to the 5th. Then what should go next? The 4x cubed, and then the 10x, and then the 7, right? Like, we like them to go in order, which is actually what is called standard form. Like, it's in here somewhere. So standard form, all that's saying is it's going in order from the highest exponent down to the smallest exponent, which I think naturally we usually do that anyway. So on this one, it's the same example we just looked at. You guys told me the one with the x to the 5th should be first. Big thing, just make sure you keep that negative that's with it, stays attached. Then the 4x to the 3rd, then the 10x, and the plus 7. All right, so that's standard form. Just in order from highest exponent down to the lowest exponent. All right, so here's where all of the terms come in that you guys need to know. All right, so first thing is your degree, because we classify them by degree, which has fancy names, and by the number of terms, which has fancy names. All right, so we're going to kind of just work through this table that has examples on it. So on this, there is no variable. So it has a degree of 0, because there is no variable. So in this example, just it being number 5, that's considered a constant. It has how many terms? 1. And do you know what you call something with 1 term? Would make sense, but no. It's a monomial. Mono means 1. Which I don't understand that, right? Like mono y mono, like man on man, one on one. But then if they say you have mono, they call that the kissing disease. But mono is 1. So are you kissing yourself? I don't understand that. Yeah. I didn't make the rules. I have no idea. Yeah, it's just monomial. Mono means 1. All right, this is an x to the 1st, which is called linear. Think about what its graph would look like. It would be a straight line. You guys remember y equals mx plus b? They always graph straight lines for you. All right, that is a degree of 1. It's called linear. How many terms does that example have? It's 2. Yes, that is a binomial. Bicycle has 2 wheels. Binomial has 2 terms. All right. All of chapter 4 had an exponent of 2, and those were x squared. That was quadratic. That is a degree of 2. Quadratic.
Isn't that where it starts being polynomial?
Technically, they're all considered polynomials. Mm-hmm. Yep, I know. That's. polygons?
Yeah, polygon.
Yeah, no matter how many sides they have. Yep, same idea. How many terms does this one have? One. Ha, you thought it was going to be a pattern. That's monomial. This one, the highest one is a 3, which I'm sure you guys are familiar with as cubic. That's a degree of 3. How many terms does that one have? 1, 2, 3, right? So many pieces are being added or subtracted. There are 3 terms. What do you call that? That is a trinomial. Tricycle has 3 wheels. Trinomial has 3 terms. All right, here's the ones that people always mess up. If it has a degree of 4, highest exponent is a 4, that is quartic. How many quarters are in a dollar? There are 4 quarters. That is quartic. There are 4 quarts in a gallon, which most people don't know that as well as 4 quarters. How many quarters are in a game of football? There are 4 quarters. Okay, so quart, trying to help you remember that. Quart is 4.
I said 12 jokingly, but like quarter is 1/4. No.
You're right. So 4. So this is 2 terms, and we call that binomial. All right, and the last one, x to the 5th, is quintic, 5th degree. This has 1, 2, 3, 4 terms. What do you call something with 4 terms? Hmm? Yes. All right, let's kind of summarize this a bit because I used to just do the table and then it really confused people. So let's just kind of put it all together. All right, so you can classify 2 ways, and we need to know the difference: degree and number of terms. Which the table did that, but I want to make sure we're really clear on this. Degree deals with the exponent. If I told you it was 32 degrees outside, where would the little degree marker go? Right? You'd be like 32 degrees. Where does the degree sign look like? What else goes up here? An exponent. Degree is based on your exponents. Trying to help you remember that, okay? Degree sign is up there like an exponent. Degree is based on the exponent, okay? So for a degree, it can be 0, which is constant, meaning it has no variables. 1 is linear. Degree of 2 is quadratic. That is probably the most missed one. Why? You think 4. People think of a quad. My brother used to race quads when he was younger. What are quads? They're 4-wheelers. That totally goes against everything like that goes with this, right? You should have been racing quarts, not quads, right? Sounds weird. But yeah, quadratic, we got to stop and think. Think of the quadratic formula. That's when you're solving when you have an x squared. Okay. 3 is cubic. Degree of 4 is quartic. And 5 is quintic. I will not require you to list any fancy names, anything beyond that. Okay, so if it was 6, you just tell me it was a 6th degree. Okay, anything higher. All right, you can also classify by the number of terms. So either 1, which is monomial, 2 is binomial, 3 is trinomial, and 4 or more is just poly. But is a monomial still a polynomial? Yeah. Is Ben a student? Is more specifically his name Ben? Right? It's kind of like this. These are all polynomials, but more specifically, I have monomials, binomials, trinomials, and then just poly. Right? It's like you are all students, but individually you all have specific names too. All right. So all of these terminology right here, you need to know those. If you do not use those correctly, it is wrong. Okay? Oh, yep. Sorry. Did I go too fast?
Yeah,
Ben?
what was the example for the degree?
Cortic? Cortic. Yep, it was up here too on our table. Yeah. I was just rewriting it to just kind of give us, like, these are the terms we need to know. So next thing we're going to do is I'm going to give you some examples. You're going to have to write them in standard form. Tell me what the degree is and by the number of terms. You're going to classify it using the fancy terms. Yeah.
Are we ever going to have to simplify these before we classify them? Okay, that's very simple as it's going.
Yep, it will.
This isn't really that difficult by itself.
No.
Like,
Mathematically, shouldn't be too bad. It's just a matter of remembering what those terms mean. All right, so the first one, put it in standard form first. So what order should it be written in? Okay, classifying it by its terms. How many terms does it have? Terms. It has 3 terms. This is a trinomial. And then by its degree, good, the degree is a 2, which is quadratic. So this is the type of answer I would look for. Standard form, classifying by its terms is trinomial, and then by the degree is quadratic. If you flip-flop, that's fine. On homework and like a quiz and tests and stuff over this, I will like literally write terms. You tell me, you know, trinomial. I'll write degree. You write quadratic. All right, what about the next one? What should be written first? Angel? Yes. If you have like terms, we got to put those together. So that's going to give you a positive 4x squared. Good. Okay, so there's standard form. Just so we're aware, like on homework and stuff, I write SF because I'm lazy. What's SF stand for? Standard form, just to make sure we're okay. All right, what about terms? You would call this a terms. That's polynomial. Sorry. Well, it shouldn't matter which order they're in. You just got to know. Terms means that's the nomials. And then degree, that is to the 4th, which is quartic. There we go. So just so we're okay, remember to think of degree. If it's 32 degrees, the degree signs up like an exponent. So that's based on your exponent. Terms is always your nomials. The fancy nomial terms. Why don't you guys, let me give you a minute. Let's do the next 2 on your own. All right, so the first one up here, what should be written first? Who wants to tell me the right order? Yeah, go ahead. Good. There's standard form. Switch it up just to mess with Hamid over there. What about the degree? It'd be what? It is quartic. Quartic is by its exponent. The highest one is a 4. And then by the number of terms, it's a trinomial. Again, because there are 1, 2, 3 pieces. Now, this problem over here cracks me up walking around. I leave it here just because it's really funny. Did you catch what was wrong? People think that's written in the correct order. You know that's not problem number 3, right? It would be problem 4 if I counted them. A lot of people did that. Cracks and they're like, yeah, look, it's fine. This is problem 3, right? No, it'd be 1, 2, 3, it'd be 4 if I was numbering them, but I did number them. So it'd be negative 4x to the 5th, 3 plus 10. That's yeah. So plus 2x squared and then plus 13. That's what it should be. Yeah. Many of you did that. It's just my own.
I
I thought it was funny.
People
People automatically just assume, yeah, it's a problem number. I don't need that.
If I look at the problem number, like, that's not very, it would have said something.
It just cracks me up.
What is it?
All right, what would you call this by the degree? Good, that'd be quintic. And by the terms, it would be a trinomial. 1, 2, 3. Yeah, it goes by your simplified version, not the original. Because there could be a whole lot of like terms that you have to put together. Okay? You caught him on one thing, and then he caught you on another. All right, questions, though, on how to use the correct terminology for those. You do need to know those, okay? So make sure you're looking over that list. All right. Next thing is talking about the graphs. Obviously, the last couple of days, last week, we were talking about graphs in here. All of our graphs will be continuous. Okay, nice, smooth, flowing, right? Nice little curves to them. They will not have sharp turns. This is an example of an absolute value graph. It actually makes a V. Ours will not be sharp. Some of yours look sharp when you were graphing those. They should be rounded, okay? All right, so let's get an idea kind of what graphs look like. So you guys have your graphing calculators. Let's go ahead and graph some of these. Go ahead and graph x squared. Do you guys remember how to make it graph? Turn it on. Hit the y equals button. I gotta say, turn it on, you know. Yeah, go ahead and draw a sketch for me of what that looks like. So let me give you a few minutes. Do all of these, right? You have a whole page of graphs. Let me give you some time. Go through every one of those graphs and draw a sketch of them for me. All right, Quinn, just draw a rough sketch of what x squared looks like. Oh, does he have a point on the bottom of that? It's like the hardest thing for people to not do is make those pointy. There we go. Good. All right. Quinn, pick somebody to come up and do negative x squared. They don't have to volunteer. J, negative x squared. She's just double checking. Negative x squared. Good. All right, so what do we think a negative's doing to it? What happened? Yeah, it just made it go the opposite, right? I flipped it over. All right, what about x cubed? Jay, pick somebody to do x cubed. You don't want to pick anybody? Somebody want to volunteer for x cubed? Ben, come do x cubed for me. I should have picked Chris, right? Where you been, Chris? Oh, gotcha. That works. Wait, arrows? 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 It keeps going, right? All right. Ben picked somebody to do negative x cubed. Chris hasn't even been in here. All right. He's going up cold. He's not even putting it in a calculator. Oh. What do you think, Chris? I'll say that looked exactly like the other one. Chris went up cold, didn't do anything, just walked in the room, and he's right. Nice job. He noticed it was negative. He knew that it flipped it. Good. Chris, pick somebody to come up and graph x to the fourth for us. Dalton. X to the fourth. Arrows? Good. All right, pick somebody to do negative x to the fourth. Dylan, negative x to the fourth. It's the only one who picked up the red pen. Good. All right, pick somebody to do x to the fifth. Hamid, is that who you're calling? X to the fifth. Those are the fun ones to draw. He just wants to make sure it goes the right way. That's not straight. Then you typed it in wrong. So it didn't go straight. Good. Hamid, pick somebody to do negative x to the fifth. You mean darn it? Shucks. She broke it. No, you're fine. You just hit that black on the bottom, which is what put it back. Now she gets to stand there awkwardly while we wait for it. There we go. Close enough, she says. It's close, but I might change this just a little bit. It's going to go back up. It's not going to keep going, veering out to the side. All right, Angel, pick somebody for x to the sixth. She's going to pick somebody who hasn't already been up there. Victor. Victor, x to the sixth. It's not a hard thing to come up to do, right? Yeah. Yeah. Does it flatten out at the bottom?
6 does.
Yeah, that's probably a little extreme. That's a bit extreme. And Victor, pick somebody for negative x to the sixth. It flattens, but you know, negative x to the sixth. What do you want? You want me to do it? That's the first time someone's ever picked me to do it. Oh, I totally missed it. All right. In other words, what does the negative do to it? It flips it. If your phone is in your hand right now, put it away. All right, so it flips it over. So some of these look alike, right? Which ones look alike? Quinn?
Even numbers are like horseshoe shaped.
Good.
Whereas odds are the sort of thing. Very specific.
Sort of the thing. I know what he's saying, but yes. Ben, were you going to add to that? Yeah, kind of. Do you want to know the technical name I use for them? Squiggly up and squiggly down. That's what I call them. Very technical. But no, you were absolutely right. So what I want to do then is look at kind of end behavior in a nutshell. Because you should be able to look at a graph or an equation and have a rough idea of the graph, right? We talked about that last week. I can tell if it's going up or down, right? Whether that first term was positive or negative. We looked at that last week. This, we should be able to tell even more so. So even exponents, you said look more like the horseshoe. I always think of kind of a smiley face, sad face kind of thing. If you're a positive person, do you smile or frown? You would smile. I'm trying to give you easy ways to remember this, guys. All right? And if you're a negative person, you frown. So if I see my exponent is even, and the number in front of it, right, its coefficient was positive, I know it's going to be, the ends of my equation is going to be a smiley face, right? They're going to go up. if you're kind of odd, you don't have a normal smile or frown, right? You're kind of odd. So if you are a positive odd person, from left to right, you go up. We read from left to right. So same idea here, and I'm looking at a graph. From left to right, it's going up, which is positive.
We're doing math in Japan.
We're not. All right? What about if you're odd, but you're a negative person? From left to right, you go down. Squiggly up, squiggly down is what I like to call those. All right, so I will ask you questions to describe for me the end behavior. Now, the ones that we just graphed, they all looked pretty much the same if they were even. Is that always true? No, it's not. All that really looked at is the end behavior, right? The ends will both be pointing up. Could there be a whole lot of curves going on in between my ends? Yeah, there could be. All right, so describe the right and left-hand behavior of each graph. Now, for me, I don't care if you just, for me, the easiest part, just draw me a rough sketch. Without graphing, I can look at this problem and be like, okay, my exponent is odd, so I know it's going to be an odd smile, right? It's not normal. And the number in front is positive. So odd, positive, it's from left to right, goes up. I know that's what its ends will look like. What about the next one? X to the fourth minus 2x cubed. The highest exponent is even. If you're even, you have a normal smile or frown, and that's positive, so it looks like a smiley face. Gotta look at the exponents. So this one, there's a lot going on up here, but what's the highest exponent? It's odd. So it's going to be a squiggly up or squiggly down. And the number in front of it is actually negative. So it's a squiggly down. From left to right, it goes down because it's negative. Yeah, it's kind of hiding out there in front. And then this one, the highest exponent is even. So it's either smiley or frown, and it is a frown. It's going to look like that. All right, so without even graphing them, I can tell you that's what the ends look like. Do I know like kind of what the curves and stuff look like in between there? Not really, but I at least know what the ends look like. So there are 4 more on here. Let me give you a minute real quick without using your graphing calculator. Draw me a quick sketch on what all of those ends would look like. All right, number 1, what did it look like? What's up mean? It looks like a smiley face. Yeah, because that is even. And the number in front is positive. Looks like a smiley face. What about number 2? Thank you. Squiggly down. Very technical name there. It's because that is odd, and that one is negative, which makes it a squiggly down. What about number 3? Squiggly up, because that is odd, that is positive, so it's a squiggly up. And number 4. That's a frowny face because that is even and that is negative. All right. Questions on how to tell what its ends look like. All right. Then the last thing we need to talk about is turning points, or all those curves that you have going on in between there. I may not be able to tell exactly what those curves look like, but I can tell you how many at most it might have underneath there. At most. Okay. Because like we graphed, what, x to the 6th, and it still just looked like a parabola. It didn't really look anything fancy. So if a polynomial has a degree of n, then the graph has at most n minus 1 turning points, or changes of direction. So in other words, if I had x to the 4th, right, it'd be 4 minus 1. It would have at most 3 turning points. That's what I was looking at. If I had x to the 7th, 7 minus 1 is 6 turning points. Does that make sense? At most, it'd be 1 less than whatever that degree is. No, it doesn't tell us where they are. It doesn't tell us how high or how low they go, but at most, that's how many it would have. So if I look at this, now this is kind of backwards. I have the turning points, right? 1, 2, 3, 4. So now it's kind of working your way backwards. If I had 4 turning points, could you tell me what degree it was? It'd be a 5th degree, right? Because if I had x to the 5th, you'd be like, okay, 5 minus 1, the most it has is 4 turning points. Well, yeah, I have 4 turning points. It's probably x to the 5th. Could it be x to the 6th, x to the 7th, x to the 8th, x to the 9th? Yeah, it could be. But it's at least x to the 5th or something higher. So if we come back for a minute and look at some of these, ooh, how many turning points would this one have? This would have at most 3 turning points. What about this one? That would be 4 turning points. This one? 2 turning points, because it's 3 minus 1. And this one would have 1 turning point. Does that make sense? Let me give you a few more examples of the opposite way. So if I gave you that's a fun graph. What degree is that? So we'd be like 1, 2, 3, 4, 5, 6, plus 1. This would be a 7th degree. Or higher. It could be higher, but it's at least a 7th degree. Depending on which direction you're going. So let's kind of clarify that, okay? So if I ask you to find the degree versus if I ask you to find the turning points. Degree is going to be your turning points plus 1. If I ask you for my turning points, that's degree minus 1. Kind of depends what I give you. But yeah, that kind of puts it together for you. All right, how are we feeling? Questions on anything we talked about? Now, some of you have been wondering about this tic-tac-toe board on my floor up here today. What? You noticed it when you walked in, right? Like, what is going on up there?